Hello fellow gamers, my name is Brent Justice and welcome to the FPS Review. We have a bit more information to share directly from AMD in regards to the AMD Ryzen 9000 series desktop processors. These are the Zen 5 architecture powered Ryzen 9000 series coming to the PC this summer. This information is being provided directly by AMD prior to the official launch. At Computex this year, 2024, AMD announced the Ryzen 9000 series among many other things, and we have a video on all of those announcements, including our written articles detailing all of that information on our website at www.thefpsreview.com. In this video today, I am going to go over all of the press presentations that AMD has sent us in regards to the Zen 5 architecture and the AMD Ryzen 9000 series CPUs, as well as some other information such as RDNA 3.5 as it relates to AMD Ryzen AI 300 series. So this is going to be a pretty packed video today, and I'm going to try to quickly go through the slides and just show you all of the information that AMD has provided us. The first slide that I'm going to start with in the presentation is actually the last slide of the presentation because it contains the most important information beside the pricing, and that's the release date. We all want to know when the release date is. Coming July 31st, 2024. That is the on-shelf date for the Ryzen 9000 series processors. That is when we can expect it. Pricing, however, not released yet at this time. We will have to wait till that time to see how much they actually cost, but coming July 31st. Now let's go all the way back up to the top. Start with the Ryzen 9000 series. Again, a lot of this information will be repetitive if you've seen the announcements from Computex 2024. So some of this is going to be repetitive, but some of this may be new information as well. And what's really new is the deep dive into the Zen 5 architecture, which we're going to take a quick look at after we look at this one. So AMD's desktop vision for the Ryzen 9000 series processors: performance leadership, energy efficiency, overclocking, that's right, platform longevity. We talked about that already at the Computex introduction. The longevity period for AM5 has been extended through 2027 and possibly even greater than that. Extreme overclocking is also interesting because AMD has been talking a lot about overclocking with this series. So let's start with the base level AMD Ryzen 9000 series, still on the AM5 platform, PCI Express 5.0, DDR5, so that is what we already knew, that's what we're getting. Here is a summary of the lineup. The Ryzen 9 9950X, 16-core, 32-thread, 5.7 GHz max boost, 80 megabyte cache, 170 watt TDP. You'll notice that is the same specification as the 7950X. The difference is in the architecture. Ryzen 9 9900X is 12-core, 24-thread, 5.6 GHz max boost, 76 megabytes cache, 120 watt TDP. Now that's different because the Ryzen 7 7900X was a 170 watt TDP CPU. This is 120, so 9900X, lower wattage than the 7900X. Ryzen 7 9700X. 8-core, 16-thread, 5.5 GHz max boost, 40 megabyte cache, 65 watt TDP. That TDP also different than the 7700X. The 7700X was a 105 watt TDP CPU. This is 65 watt. And then we have the Ryzen 5 9600X, a 6-core, 12-thread, 5.4 GHz max boost, 38 megabyte cache, 65 watt TDP. And again, that's lower than the 7600X, which was a 105 watt TDP. When we talk about performance, AMD is comparing the 9900X to a 14900K. They have productivity and gaming they are showing here. Procyon, Geekbench, Puget, Blender, Handbrake for content creation things. And then games here focusing on Borderlands 3, Dota 2, Hitman, Cyberpunk, F1, and Horizon Zero Dawn, not Forbidden West. Now we can see that this can scale all the way from a very, very low single-digit score, which would be practically the same performance as the competition, all the way up to potentially 20%, 30%, 40% in productivity. In gaming, could be up to 22%. All of this is going to depend on the games and obviously the other hardware that you're running. Now, I did check the end notes on this, and AMD is using a 7900 XTX GPU to compare those gaming benchmarks, so we are not as GPU bound in the gaming benchmarks that it is showing here in this performance. So this performance would be showing a more realistic and real-world CPU performance difference with that high-end GPU. I did check those end notes just to make sure. The 9700X is being compared to the 14700K, and again, we see some different content creation things here and games as well. 7-Zip, Procyon, Geekbench, Puget, Handbrake, and then Borderlands, Dota, Hitman, Cyberpunk, F1, Horizon, anywhere from 4 to 31% against the 14700K. So again, just keep in mind these are all first-party benchmarks from AMD. Reviewers will need to get their hands on and test these. Always look at multiple review sites to see what the performance is actually in the real world. Moving on, the 9600X versus 14600K. Again, we see different content creation apps here, anywhere from 8 up to 94% in Handbrake, and that could just simply be a core difference. Not really sure. That one's kind of an outlier to me, but we will have to look at that performance and see what it actually is ourselves. Gaming leadership, 5% to 29%. Again, really going to depend on the game, because some games, if they're down in that 5%, 2% range, I mean, that is practically the same performance. You're not going to notice that difference. So it really is going to come down to the game a lot here. AMD is also showing that the 9700X specifically, which is a 65-watt CPU, can compare and be as fast or faster in some games than the 5800X 3D, which is a 105-watt TDP CPU. Now, the 5800X 3D is a couple of generations back. It is on AM4, DDR4, so this is not the 7800X 3D. The comparison there could be more interesting, and I am sure that people will want to know what that is. We will just have to see how that turns out to be when we actually are able to do real-world benchmarks ourselves and figure that out. But I think that the point of this chart that AMD wants to show is that a 65-watt CPU in this generation can beat a 105-watt CPU a couple of generations ago, one that in fact was and still is very fast for gaming because of the X3D cache. Because pricing, power, performance, all of that in that sphere is going to be very close, and it's really going to matter, and it's going to come down to the small details in that space. And that, again, is something that reviewers will have to look at. We will have to get our hands on the hardware. We will have to directly test that and see how does the power compare, how is that performance, and of course, very importantly, how is the price. AMD will be emphasizing the less power usage, as we just mentioned, the cooler systems not needing such a high-end AIO or air cooler for these CPUs this generation. And part of that is a 15% reduction in thermal resistance, or an improvement, I should say, a 15% thermal resistance improvement leading to a temperature reduction. Now, what that can ultimately lead to is perhaps higher sustained clock speeds or boost clocks on the CPU. And we will just have to see again how that plays out. We could be potentially seeing a full all-core workload CPU frequency that can sustain at a higher level throughout the power curve. And again, more testing will have to be done from third-party reviewers to see how that plays out, but AMD is showing that efficiency improvement. This chart really emphasizes what I also want to emphasize, and that's the fact that the 9900X has moved from what the 7900X was, a 170 watt TDP part, to now 120 watt TDP, and then the 9700X and 9600X have moved to 65 watt CPUs compared to the 105 watts of their predecessors. And so there has been a reduction in power, but at the same time, a performance increase. 22% here, Ryzen 9 16 core, 16% with the Ryzen 9 12 core, the Ryzen 7 8 core 11%, and the Ryzen 5 6 core 17%. And that's at, again, lower power. Now that is the thermal design power. How that actually translates to the real world power draw will have to be tested by third-party reviewers like us. We won't know that. But at least from a thermal design power, it has been lowered. So AMD is also emphasizing some overclocking enhancements with the Ryzen 9000 series. Part of that is AGISA updates that allow up to DDR5 8000. Now, will it really do that? Will we really hit that on each CPU? Don't know. We will have to test that. We do memory testing as well on our channel. We do memory reviews, so we will have to look at that with different memory kits and see if that is obtainable. Also, new memory overclocking on the fly and memory optimized performance profile features, memory overclocking enabled on all AM5 consumer chipsets, and JEDEC support for DDR5 5600. Also, a new curve shaper overclocking feature, which should allow more people to overclock their CPU, but at the same time undervolt and actually get a lower power profile with that performance as well. And there is a slide to show that, and so we'll take a quick look at that. Precision Boost Overdrive, one-click overclocking, still a thing, and in fact, AMD is emphasizing that more this generation. Ryzen 9 9900X could get up to a 6% boost of performance just by enabling PBO. The 9700X has an abnormally high 15% compared to the other CPUs, and the Ryzen 5 9600 is 6%. We will again have to test these, but a simple one-click turn on PBO and you have instantly better performance. Of course, you're going to have higher power too. That is something that we saw in the last generation as well. That was a real thing, and where we really saw the benefits of PBO was in last generation's Ryzen non-X CPUs. In those, they were 65 watt CPUs, and by turning on PBO, you could get higher power, and we actually saw a pretty good performance boost with those CPUs nearing their X counterparts just by turning on PBO. So it'll be interesting to see where these X CPUs are able to hit with PBO enabled. Definitely looking forward to testing that, get a little bit extra performance with a single click. And again, the longevity here is something that is talked about. AM4 has lasted quite a while, 145 CPU and APU models to date, nearly 9 years of new products, including AMD 3D V-Cache was introduced on AM4. With AM5, 38 CPUs and APU models currently and growing, extending the longevity through 2027 plus. AMD has already said that. Should make people feel a little bit better about buying into the AM5 platform now. Along with this, AMD has announced already at Computex the AMD X870E and AMD X870 chipsets. That was announced at Computex, but what's new here is AMD is also showing now the AMD B850 and B840 chipsets. So a refresh of the previous chipsets, and we're getting an 850 and an 840 series of that. Now, these are all on the AM5 socket, so you are not required to buy these chipsets in order to run the Zen 5 architecture Ryzen 9000 series CPUs. These are not required. These are just going to be some new motherboards that will be out by vendors with these new chipsets, and some of the features you will get are on the 870 and 870E. USB 4 is mandatory on those, but one change on the AMD X870 is, unlike the X670, the graphics and the NVMe will be PCIe Gen 5. So you could have had like either or on the X670, and now it is graphics and NVMe are definitely going to be Gen 5 on X870 motherboards. Also with AMD B850, you get Gen 5 NVMe or graphics, and that's optional. But you will get Gen 4 graphics. It's just that graphics is optional on the B850. And USB 3.2 20 gigabit, and the AMD B840. Now that is a Gen 3 PCIe motherboard, so be cautious on that one. If you go all the way down to the 840, you're Gen 3 PCIe. Just keep that in mind. So I think most gamers would want to shoot for the B850 or above if you're getting one of these new motherboards. But I suppose that would be a value option with the B840. We'll have to see what the prices are like. Again, it would still be AM5 and it would still be DDR5. It would just be PCIe Gen 3. Moving on. AMD Ryzen AM5 platform for serious AI performance, the ultimate enthusiast AI platform, content creation, development, and productivity. Enthusiast AI graphics, no compromise with AMD socket AM5. So they are showing that the bandwidth you get between the CPU and the GPU and the NVMe using PCIe Gen 5 is going to allow for these large language models to be transferred between each with that bandwidth on Gen 5. And also the ultimate enthusiast AI platform because of that. Just a couple of token benchmarks here and how AVX 512 can really be beneficial with Zen 5. And again, this is the lineup, a summary of the lineup coming July 31st. That's the lineup. So a lot of this information was already known, but let's show off some more new information by going into a little bit of a deep dive with the architecture of Zen 5. We're going to quickly go through it and leave it a little high level, but let's go through it now. So this is going to be just a high-level look at the Zen 5 architecture. You can pause the video if you'd like to read these slides in greater detail, but we're just going to read them quickly and give a high-level overview so you are a little bit familiar with the Zen 5 architecture going into the Ryzen 9000 series. So, foundations of core architecture, more instructions delivered per cycle, dispatch and execution expanded with doubled cache data bandwidth, AI acceleration. So we'll start with the dual pipe fetch with advanced branch prediction. Branch prediction, less latency, more accuracy and throughput, instruction cache latency and bandwidth improvements, and dual decode pipes, and that's this section up here. Wider dispatch and execute. 8 wide dispatch, retire, 6 ALU, 3 multiplies, more unified ALU schedule, large execution window. Increased data bandwidth. 48 kilobyte 12-way L1 data cache force cycle load, double the maximum bandwidth to the L1 cache and floating point unit, and an improved data prefetching. 512-bit AI data path, AVX 512 with full 512-bit data path, 6 pipelines with 2-cycle latency FADD, large number of FP instructions in flight. The Zen 5 IPC uplift for PCs, GeoMean versus Zen 4. We've seen this before, 16% average IPC uplift. And again, this is just going to really depend on, well, a lot of things. AMD is taking game and productivity in consideration of this IPC uplift. So consider that. We will just have to see. Now, also consider IPC uplift is not necessarily performance. That is instructions per clock. And how that is calculated can be a little bit different. So that does not translate directly into 16% performance. Just keep that in mind. This is IPC. What the actual performance is, we will have to test. Breakthrough performance for math acceleration unit, improvement compared to Zen 4. So AMD is claiming an up to 32% single-core machine learning and up to 35% single-core AES XTS. when you summarize and put everything together into how AMD has improved the Zen 5 IPC, it is an improvement in data bandwidth, an improvement in the fetch/branch prediction, and the execution/retire, as well as decode/op cache. And that is a summary of that. Also, a node change. So faster, smaller, lower power transistors, optimized power efficiency, 4 nanometer and 3 nanometer leadership process technology, enhanced metal stack, continued deep partnership with TSMC, multiple products in development, module designs, desktop server client, and embedded. The Zen 5 architecture spreads the entire product portfolio. So if we go back and look a little bit more at this information, this is a breakdown of the CPU pipeline. And you can kind of see here the improvements that were made. And this shows that it is not simply a cut and paste of Zen 4 to Zen 5. This is, in fact, actual improvements in the architecture of Zen 5, which allows IPC improvements, which by way of that will allow performance improvements. And a lot of that will depend on the app or application program you're using and how it uses or utilizes those portions of the CPU. So just keep that in mind. We will have to see how it all translates, of course, to gaming performance, productivity. All of it will have to be tested by third party. Now, let's talk briefly about Zen 5 overclocking, because AMD has been emphasizing overclocking on these CPUs quite a bit, and that does not just include memory overclocking by running that at faster frequency. In fact, AMD has Curve Optimizer and Curve Shaper. Curve Shaper is what's new. Curve Optimizer has existed before, but the Curve Shaper is new. So let's first talk about what the Curve Optimizer is. Curve Optimizer is a legacy feature from the Ryzen 7000 that allows the user to enable a PMFW PBO aware undervolting. The feature works by shifting the curve a dynamic amount of Curve Optimizer steps. These steps give variable voltage across the curve, more voltage at higher frequency. Curve Optimizer can be applied per core, per CCD, or per CPU. Now here's what's new. Curve Shaper builds on this feature and allows end users to now reshape the underlying voltage curves to maximize how they undervolt their CPU. Curve Shaper takes the same steps but allows the user to selective add or remove them from 15 different frequency / temperature bands, 3 temperatures, 5 frequency. This allows users to further reduce voltage from bands that are stable and add voltage for bands where instabilities are observed. The reshaped curve applies to all cores and can be shifted by Curve Optimizer. There's probably a lot of potential here, and if you know what you're doing, this could be very beneficial if you are really, really into tweaking your CPU. Now, if you just want to run your CPU at stock, that's great. And if you want a simple overclock and you are okay with a power increase, PBO is there. And that's probably the easiest way to get the most performance. Now, the next thing to talk about is the AMD Ryzen AI 300 series coming to mobile. This, of course, includes the Zen 5 architecture CPU component, as well as the new RDNA 3.5 graphics component and the NPU. We talked more about this at the Computex launch, so in our video there, you will find more information about the Ryzen AI 300 series. We are not going to go over all of that today. In fact, what I want to talk about today is actually more related to the graphics side of Ryzen AI 300, and that is the RDNA 3.5 graphics architecture that is in Ryzen AI 300. But before we look at that, AMD does have some new slides here showing how the Ryzen AI 300 series can compare to some of the competition, including the Intel Core Ultra 9 185H, Snapdragon X Elite, and of course, it doesn't show here Lunar Lake. The Intel Core Ultra 9 185H is, of course, Meteor Lake. So the Intel Core 200 series would be Lunar Lake. And of course, that would probably be the more interesting comparison that everyone wants to see. But right now, all we have is the comparison to Meteor Lake. But AMD is showing that in benchmarks here, Procyon, web browsing, PC Mark, an improvement over, well, everything, over all of the competition, 1.07x, 1.13x, 1.21x, 1.3x in web browsing. Again, first-party benchmarks, take this for what it is. Third-party benchmarks will need to happen. When we look at content creation, Cinebench, it is up compared to Meteor Lake, but apparently it's down a little bit from Snapdragon. So that's interesting. Now, digital content creation up a little bit. Cinebench 2024 with more threads than one thread. That was one thread. With all threads is pretty much almost the same performance as the Snapdragon, but a little bit higher, beating Meteor Lake. Handbrake up there at 1.6x, and then 3D rendering way up there at 3.8x. Again, first-party benchmarks. We look at gaming performance, which I'm sure you all are really curious about, and again, the RDNA 3.5 is what I want to focus on in this video. But you'll notice there's a few games here that just would not run in their testing on Snapdragon X Elite. And then we do have Meteor Lake beating the Snapdragon in the gaming performance. And we have the Ryzen AI 9 HX370 at 1.27x faster in Far Cry 6, 1.36x faster in F1 2022, 1.36x in Shadow of the Tomb Raider, got Borderlands there, and Assassin's Creed. Those are all about the same, so about 30-something% faster in those games. GTA 5, though, is almost there at 50% faster, and then Cyberpunk's way up there at 65% faster than Meteor Lake. But again, I think the real interesting comparison here would be Lunar Lake. We just don't have those benchmarks yet, and again, they would just be first-party benchmarks, so we've got to wait until people actually test that. But let's talk about the Radeon 890M graphics, or RDNA 3.5. AMD has finally shared some information on RDNA 3.5 and maybe how that differs a bit from the RDNA 3 architecture, which was in the latest generation of APUs from AMD, including also, of course, the desktop GPUs with RDNA 3. So RDNA 3.5 is an iteration of RDNA 3. It's a little bit better, but it's not RDNA 4. But finally, we can see what makes it a little bit different. So this leverages deep collaboration with its mobile partners. It's optimized AMD RDNA 3 architecture for power and performance efficiency. So it's not necessarily geared for a complete 180 on performance. It is geared for more power to performance efficiency, since this will be in mobile. Optimized for performance per watt, improved the performance and efficiency of many common graphics shader operations. So that's about improving the efficiency, because battery life will be everything with the Ryzen AI 300 series. Optimized for performance / bit access memory less often and more efficiently. Again, the less you need to access the memory, the less you have to spin that up and waste power. Designed for better battery life. Advanced power management in the GPU to save active power. So there's a lot of work here on reducing power and improving efficiency with RDNA 3.5, which makes sense for Ryzen AI 300 series. So in the performance per watt category, a 2x texture sample rate. Subset of the most common texture sampling operations are now double rate for common game texture ops. So they have doubled that rate for common texture ops, and that should improve performance but also wattage. 2 times interpolation and comparison rates. Most of the rich vector ISA for interpolation and comparison is now a double rate for common ops in shaders. Again, about improving that performance per watt by doing basically double rate work. Improved performance bit, improved memory management, improvements to primitive batch processing to reduce memory access, better compression techniques, workload reduction, and optimized LPDDR5 access. So all of that is in regards to the memory system and reducing the necessity to use the memory system, better compression, better access, reduced access reduction, and optimized for LPDDR5 helps reduce power. So all of this is focused on the power reduction there. Now, AMD also has released some common benchmark results here. 3D Mark Time Spy, and note this is the 15 watt Strix Point versus the Hawk Point last generation 15 watt as well. So these are the same wattage CPUs here, or graphics, and we can see that AMD is quoting an up to 32%. Notice up to, so that's like the max, not necessarily the average you'll get. But in this particular benchmark, 32% better performance because of those changes. Also in Night Raid, a 19%, and that's, again, we don't know what the average will be, but two very different results here, and 119, 132. So what will it end up in games? We'll have to see again. But between a 19 to 32% perhaps. So that kind of shows you the potential of RDNA 3.5. So again, it's about a leap forward with the Zen 5 architecture in Ryzen AI 300. You've got the improved compute performance and efficiency with RDNA 3.5 and the power management. And that's going to be the end of the presentation. This is most of the new information that AMD is releasing prior to the launch of the AMD Ryzen 9000 series desktop processors coming here. Now we know July 31st, 2024, July 31st. Of course, with all of the benchmarks shown today, keep in mind these are first-party benchmarks by AMD. However, we did check the end notes, and all of the gaming performance was shown with a 7900 XTX. So a high-end GPU was used for those comparisons. Of course, third-party reviewers will have to take a look at the performance and compare everything, and I cannot wait to get our hands on it and do real-world benchmarks, real-world gaming, and as well as synthetic, and see how all of these CPUs actually line up in terms of performance versus the last generation, and power as well. And in fact, I want to focus a little bit on the power, because I think that's really the big story here. The fact that in the 9900X, AMD has reduced the TDP from 170 watt to 120 watt, and then the 9700X and 9600X becoming 65 watt TDP CPUs compared to the 105 watt of the 7700X and 7600X. At the same time, performance has been increased. So a TDP reduction and a performance improvement. So they are operating at less power, but a higher performance compared to the last generation. So when we take all of that into consideration, we have almost a perfect storm of what you would want from one generation to another. A generational improvement, you would want a performance increase at a lower power. That shows a generational improvement. And you would want pricing that is competitive, at least similar to the launch pricing of the previous generation, if not lower. We don't know the pricing yet. That is going to determine a lot. However, we are close to that perfect storm of all three pegs being put in that board, and that is performance, power, and pricing. The three Ps, literally. And we have two of those Ps nailed. Now let's see if AMD can nail that final P, the pricing. What this shows to me, however, is as many might have you want to believe, Moore's Law is not dead. We are seeing improvements. We are seeing generational improvements in power, performance, efficiency. Once again, how all this plays out in the benchmarks is yet to be seen. We will have to get these, do some real-world testing, and remember to check multiple websites for reviews, not just one. Take all of these into account. Watch, listen, read many reviews. Take all of the information that people are testing and draw your own conclusions. Because how a reviewer configures a test system, the games chosen, the benchmarks chosen, the configurations tested, how the configurations are set up, all of these can produce different results and provide different conclusions on these CPUs when they launch. Keep that in mind when you watch reviews for these products as they are launched. As always, though, I hope you have enjoyed this video and learned a little something today. Check out our main website, www.thefpsreview.com, where we will have written reviews of these CPUs and YouTube videos as well with the performance results. 2024, the latter half of 2024, is going to be all about CPUs, chipsets, motherboards. It's going to be a very exciting time for anybody who's looking to do a platform upgrade, a CPU upgrade, a motherboard upgrade. This is the time to look into that, this latter half of 2024. I am looking forward to it, and I hope you all are as well. As always, thank you for watching. I hope you have a blessed day, and stay tuned for the next one.